Euclid, tons of dead fish, hundreds of them floating in the lake and washing ashore.
Health warning issued in El Dorado County. Officials have detected elevated levels of E. coli at Lake Tahoe.
Officials in Lake Tahoe are telling people to avoid a popular beach because of E. coli in the water. No illnesses have been reported, but people are advised to stay out of the water until it clears up. Tests in other parts of the lake came up clean.
Microplastics have been discovered in Lake Tahoe for the first time, and researchers are trying to determine the source. Plastic products like flip-flops, toys, or toothbrushes to things that are being carried from elsewhere.
The white dinner plate disappeared at 61 feet. For decades, that same plate remained visible past 100 feet beneath Lake Tahoe's surface. This single measurement reveals a catastrophe unfolding in one of America's most pristine waters, a collapse so severe it defies everything scientists thought they knew about environmental restoration. What's happening at Lake Tahoe challenges our fundamental understanding of how lakes work. Despite spending $2.3 billion on restoration since 2000, implementing the strictest environmental regulations in the United States, and reducing pollution to levels lower than 1980, the lake's legendary clarity continues vanishing at the fastest rate ever recorded. The implications stretch far beyond one mountain lake. This is about discovering that 40 years of environmental science might have been solving the wrong problem. Lake Tahoe sits 6,225 feet above sea level, straddling California and Nevada in the Sierra Nevada mountains. 22 miles long, 12 miles wide, and 1,645 feet deep, it holds 39 trillion gallons of water, enough to supply every American with 50 gallons daily for 5 years. But volume never defined Tahoe. Clarity did. When UC Davis researchers began systematic monitoring in 1968, they employed a deceptively simple tool called a Secchi disk, a white plate lowered into water until it vanishes from view. That depth measurement captures everything affecting light transmission through water. In typical mountain lakes, the disk disappears between 3 and 15 feet. At Lake Tahoe, it remained visible past 102 feet, 6 times clearer than other alpine lakes, so transparent that Mark Twain allegedly claimed you could see a drowned man at 180 feet. That extraordinary clarity created a $5 billion tourism economy. Real estate prices along Tahoe's shores command premiums 40 to 60% higher than equivalent mountain properties without lake access. People travel specifically to experience water so clear that bottom rocks appear touchable from 20 feet above.
Officials in Lake Tahoe are telling people to avoid a popular beach because of E. coli in the water. No illnesses have been reported, but people are advised to stay out of the water until it clears up. Tests in other parts of the lake came up clean.
All because of algae and shrimp. In 2019, in fact, the lake's clarity averaged almost 63 feet. The problem, the shrimp, called mysis, were intentionally taken to the lake decades ago to serve as trout feeders.
Microplastics have been discovered in Lake Tahoe for the first time, and researchers are trying to determine the source. Plastic products like flip-flops, toys, or toothbrushes to things that are being carried from elsewhere.
The entire regional economy built itself around one defining characteristic. You could see deeper into Tahoe than any other major lake in North America. Dr. Jeffrey Schlato, director of the UC Davis Tahoe Environmental Research Center, has monitored this decline for 3 decades. His 2024 measurements show something unprecedented. The lake lost 8 feet of clarity in just 3 years, not gradually, not predictably. The decline accelerated beyond every model his team developed. The Secchi disk now vanishes at 61 feet, a 40% reduction from historic levels.
The UC Davis School of Veterinary Medicine to launch a program that actually harvests those shrimp.
The goal of actually removing enough mysis from Emerald Bay, look at the whole span of time, and especially on the minimum temperatures, it's getting warmer.
Here's where the mystery deepens. Lake Tahoe receives less nutrient pollution today than in 1980. Phosphorus inputs dropped 30%. Nitrogen levels declined similarly. Erosion control improved dramatically. Stormwater treatment expanded across the entire basin. Every intervention designed to restore clarity was implemented with scientific precision and massive funding. Yet clarity continues collapsing faster than ever recorded. The conventional explanation should work like this. Development increases nutrients. Nutrients feed algae. Algae clouds water. Reduce nutrients, improve clarity. Simple cause and effect that guided decades of policy. Except the data now shows the opposite. Fewer nutrients entering the lake. Clarity declining faster. The fundamental relationship that justified billions in spending appears broken. Dr. Schlotow's team discovered the first clue around 2010. Water samples during periods of poor clarity revealed something unexpected. Algae concentrations hadn't increased proportionally, nutrient levels showed no corresponding spike, but fine particle concentrations, particles smaller than 16 micrometers, had increased by factors of 3 to 5. The lake wasn't becoming more eutrophic, it was becoming more turbid. These microscopic particles behave differently than larger sediments. Sand settles quickly. Fine particles remain suspended for months, continuously scattering light, creating persistent cloudiness that traditional treatment systems cannot address. The discovery forced researchers to reconsider everything about Tahoe's clarity crisis. The Tahoe Basin contains over 300 miles of roads. Winter maintenance requires applying sand for vehicle traction. Spring snowmelt washes this material toward the lake. Since 2000, agencies invested $400 million installing stormwater treatment devices. These systems successfully remove 75 to 80% of sediment by mass, but analysis revealed a critical flaw. The treatment infrastructure captures sand and coarse particles larger than 50 micrometers, material that would settle naturally anyway. Fine particles smaller than 16 micrometers pass straight through. The very systems designed to protect clarity were selectively removing only harmless particles while releasing those most damaging to transparency. Then came the wildfires. The 2007 Angora fire destroyed 254 homes. The 2021 Caldor fire burned within miles of South Lake Tahoe. Researchers at the Desert Research Institute analyzed sediment cores from Tahoe's bottom. Chemical signatures can differentiate wildfire ash from erosion sediment. The cores revealed dramatically increased ash deposition beginning around 2000, coinciding precisely with accelerated clarity decline. Wildfire ash contains extremely fine particles that remain suspended indefinitely. The Caldor fire provided an unintended experiment. The first major rainstorm after the fire sent particle concentrations 40 times higher than normal into the lake. The following summer recorded the worst clarity in monitoring history, 59.1 feet. While clarity partially recovered to 64.9 feet in 2023, the 2024 measurement showed renewed decline despite no major fires. Something beyond episodic ash pulses was sustaining the problem. Climate change emerged as the third factor. Lake Tahoe's surface temperature increased 1.8 degrees Fahrenheit since 1970, seemingly modest but sufficient to fundamentally alter the lake's behavior. Warmer surface water creates stronger density differences with cold, deep water. This stronger stratification means less vertical mixing. Fine particles suspended near the surface stay concentrated in the upper 60 feet, exactly where clarity measurements occur. Dr. Schlotow's instruments documented this effect. During strongly stratified summers, particle concentrations in the measurement zone increased 60% compared to weakly stratified years. The lake's changing temperature structure was keeping clarity-reducing particles in the visibility zone longer than historically normal. The biological community shifted too.
Essentially what happened was all those stronger winds that we saw back on Thursday to usher in this more comfortable weather. The problem is that water doesn't have a lot of oxygen, that cooler water doesn't. And so that's why the fish then struggle to breathe. Mindful of that, especially if you did have some lake plans over the next couple of days. It's not to say don't go out and enjoy some time in Lake
Tahoe historically supported mainly diatoms, single-celled algae that sink rapidly. Recent surveys documented increases in filamentous green algae and colonial cyanobacteria, species that form clumps and remain suspended. Warmer waters favor these floating species over sinking diatoms, another feedback loop reducing clarity. The pieces finally assembled into a complete picture. Lake Tahoe's clarity decline results from converging factors: fine particles from stormwater that treatment cannot capture, wildfire ash that remains suspended indefinitely, warming temperatures that strengthen stratification and keep particles floating longer, and shifting algae communities favoring suspended species. Each factor alone would cause manageable clarity loss. Combined and interacting, they create systematic transformation toward persistent turbidity. This convergence reveals why restoration efforts failed. The problem isn't excessive nutrients anymore. It's fine particles from sources largely beyond local control. Wildfire frequency responds to regional climate patterns. Lake temperature responds to global atmospheric warming. Stormwater treatment technology cannot capture particles small enough to matter. The factors driving clarity loss operate at scales that local management cannot address. The ecological consequences ripple through the ecosystem. Native Lahontan cutthroat trout evolved to hunt in extreme clarity, using specialized vision adapted to transparent water. As clarity declines, these adaptations become disadvantages. Lahontan populations declined 90% since the 1960s. Introduced species like kokanee salmon and rainbow trout evolved for turbid waters, increasingly dominate.
Health warning issued in El Dorado County. Officials have detected elevated levels of E. coli at Lake Tahoe.
Euclid, tons of dead fish, hundreds of them, floating in the lake and washing ashore.
Although no illness has been reported, people are being advised to avoid swimming between Jamison Beach and Valaha Boathouse.
The lake bottom tells another story. Historically, sunlight penetrated deep enough to support plant communities exceeding 300 feet depth. As clarity declines, this photic zone has shrunk by 40 feet. Approximately 2,000 acres of lake bed no longer receive sufficient light. Invasive Asian clams thrive in these darker conditions where visual predators struggle. Economic impacts accelerate as clarity crosses psychological thresholds. Tourism marketing promoted Tahoe as the clearest lake in North America for 60 years. As actual clarity drops below 65 feet, that narrative rings hollow. The South Lake Tahoe Visitors Authority found that 68% of first-time visitors rated water clarity positively. Only 41% of return visitors who remembered the 1990s felt the same. This perception gap contributed to a 7% reduction in repeat visitation between 2015 and 2023. For a $5 billion tourism economy, that represents $350 million in lost annual revenue. Real estate markets systematically priced this decline. Lakefront properties appreciated 12% slower than equivalent mountain properties between 2020 and 2024. That reversal represents $2.3 billion in foregone property value appreciation, not sudden collapse, but steady erosion of the primary asset underpinning regional wealth. Agencies scramble with new programs. The Lake Clarity Crediting Program, launched in 2015, created a market for particle reduction. Property owners earn credits for erosion control. Developers must purchase credits to offset project impacts. By 2024, over 1,200 projects generated credits representing 5.2 million pounds of particle reduction. Models predicted 2.5 feet of clarity improvement. Actual clarity continued declining. Forest fuel reduction represents another massive effort. The basin contains 200,000 acres of fire-prone forest. Current treatment addresses 8,000 acres yearly. Completing one rotation requires 25 years, but forests need treatment every 10 to 15 years. Capacity falls short by half. Every solution encounters fundamental limitations. Stormwater infrastructure costing $620 million captures only 40 to 50% of problematic fine particles. Climate adaptation proposals like artificial mixing would require hundreds of stations costing $400 million. The South Shore restoration, completed for $34 million, reduces particle loading by approximately 1%. By late 2024, the pattern became undeniable. Every intervention proved technically successful but cumulatively insufficient. Agency communications shifted subtly. Restoring clarity became protecting clarity. Dr. Schlato summarized, "We're racing between reducing controllable impacts and accelerating uncontrollable factors. Right now, uncontrollable factors are winning." The question has transformed. No longer whether Tahoe returns to 100-foot clarity. That threshold is permanent history. Now it's whether clarity stabilizes around 60 feet or continues toward 40 or 30 feet. At 60 feet, Tahoe remains notably clear. Tourism survives, though diminished. At 40 feet, Tahoe loses any claim to exceptional clarity, requiring complete rebranding. At 30 feet, Tahoe becomes unremarkable. Communities built on selling access to extraordinary water face existential questions. Which future arrives depends almost entirely on factors beyond local control. Global warming intensity, wildfire frequency, atmospheric particle loads. We're discovering that lake clarity responds not to good intentions or restoration investments, but to accumulated human impacts across scales from local to global. The monitoring continues. Projects generate reports showing progress on metrics increasingly disconnected from actual clarity. Beneath the surface, particles of ash and silt continue their suspended dance, scattering light, transforming character. Lake Tahoe isn't dying. It's becoming something other than what made it legendary, less clear, more ordinary. Who pays the price for assuming a lake so pure could absorb unlimited impacts while maintaining the exceptional clarity that created its value? That question has no comfortable answer, only steady decline of measurements and growing realization that some transformations cannot be reversed, only managed. The white dinner plate that once remained visible at 100 feet now vanishes at 61. Tomorrow it may disappear at 50. The day after, who knows? The real lesson from Lake Tahoe extends beyond one mountain lake. It's about discovering that complex systems don't respond to simple solutions, that spending billions addressing yesterday's problem won't solve tomorrow's crisis, that some changes, once begun, develop their own momentum beyond human control. We thought we were restoring a lake. We were actually documenting transformation while pretending we could stop it. That's it for today, folks. See you in the next video.